In this lesson, we're going to look at A2U8L8 in rational equations. We've been looking at rational expressions, and we've learned how to simplify them. We've learned how to multiply and divide them. We've even learned how to add and subtract them. So now we're going to take all those skills and we're going to use them when we solve a rational equation. So we're going to be getting an answer this time. X equals a number. Now the method that we're going to use is the cross, multiply, and solve. There's some other methods. You may want to find one of those, but the one I'm going to use is cross, multiply, and solve. Before we get started, you will need to check your answers because there are things that are outside of the domain. And that's primarily going to be when you have a denominator equal to 0. You don't want to plug your answer in and find that your original expression has a 0 in the denominator, so that's because that's undefined. But anything else is pretty much fair game. So let's just get started. We're going to take this problem and cross multiply. It doesn't matter whether you go left to right or right to left, whatever, as long as you do top to a bottom. So that's going to give us 7x equals bottom to a top, 4 times x minus 6. And that's the cross multiplying. Now, the equation solving is usually where most people have problems, and this is previous skills. But I'm going to step through it, pretty slowly. 7 times x is 7x. When I distribute the 4 in here, I get 4x minus 24. Subtract 4x from each side, gives you 3x is equal to negative 24. Divide both sides by 3, and x is equal to negative 8. Now, let me check my answer to see if this is correct. If I fill that in, I've got 7 over negative 8 minus 6 equals 4 over negative 8. You fill it in for all the x's. So here I have 7 over negative 14 equals 4 over negative 8. Reducing gives you negative 1/2 equals negative 1/2. So the answer works, and it does not create a 0 in the denominator. So that's your answer. Now let's look at r over r minus 1 equals 4 over r. The fractions have been condensed to a single fraction on either side, so I'm ready to cross multiply and solve. So r times r gives me r to the second power. And then on the other side, I'm going to have 4 times r minus 1. So let me simplify this real quick. R squared is equal to 4r minus 4. So I'm ready to solve. Now at this point in your algebra career, the word solve an equation, that's a big, broad area. What I have right here is not a linear equation. I have a quadratic equation. So how do you solve quadratics? One way is your zero product property. So I'm going to get all my terms over here, 0 over here, factor and solve. This would make me subtract 4r from each side and then add 4 to each side to get it in standard form. Now I'm ready to factor this trinomial. So I'm going to have r and r. Plus tells me I've got the same sign, and this tells me what they are. I need a pair of numbers that multiply to give me 4 and add up to give me 4. So that's going to be 2. Now, you're going to take each factor and set it equal to 0. Fortunately, these are the same, so there's really no need to do it twice because you're going to get r equals to 2 on both of them. Now, this is your answer. So let's plug it in over here and check it to be sure that we don't have an extraneous root. All right, if I take 2 and plug it in for all the r's, I'm going to have 2 over 2 minus 1 equals 4 over 2. So I've got 2 over 1 equals 2. 2 is equal to 2. There was not a 0 denominator created. So that's your answer. So the first two are pretty simple. Let's bump it up a notch. Now I've got 4/3 minus 7 over n equals 1/6. As I told you in the beginning, the first thing you have to do is combine either side into a single fraction. So the first thing I'm going to do here is combine this into one single fraction. And we're going to do that by subtracting. What do you have to do when you subtract fractions? Well, you're going to need a common denominator. I have 3 in n. The common thing between those two is just to multiply both of them together. So I'm going to have a new fraction whose denominator is 3n. So I asked myself, what did I do to the old denominator to get the new one? Well, I multiplied this by n, so I'm going to multiply the top by n and get 4n. Now I come over here, it's going to be minus because this is minus. N, I started with n. What did I do to n to get the new denominator? I multiplied it by 3, so I have to multiply the top by 3. That gives me 21. I'm not going to do anything to the 1/6 right now. But this does create an equation that I can cross multiply and solve now. So here's my first thing. I'm going to multiply 6 times that 4n minus 21. So I've got 6 times 4n minus 21 equals 3n times 1 is just 3n. All right, now let's simplify. So I'm going to have 24n minus, and 6 times 21 is 126. All right, simplifying, just solving a linear equation. I'm going to subtract 24n from each side. So now I have negative 126 is equal to negative 21n. All right, divide both sides by negative 21. And n is equal to 6. 126 divided by 21 is 6. Now, let me check my answer to be sure I have no extraneous roots. If I plug this in to 4/3 minus 7/6, I do not have a 0 in the denominator, so I'm good. And 1/6, then I need to get a common denominator, which would be 6. What'd you do to the old denominator to get the new one? You multiplied by 2, so I have 8. I did nothing here, so that doesn't change. 8 minus 7 is 1/6 equals 1/6. My answer checks. So there you go. Good workout in fractions and common denominators anyway. So let's look at another one. And sometimes a problem comes along that makes you do what you said you weren't going to do. And this is one of them. Normally, my go-to is to combine this side into one fraction and then cross multiply and solve. But it catches my eye that this is actually a factor of this. P squared minus 4 factors into p minus 2, p plus 2. It's a difference of 2 squares. So I can kind of do something really quick here to get rid of all the fractions, and that is multiply by what would be a common denominator for all 3 of them. So that's what I'm going to do. I'm going to multiply every single term by p minus 2, p plus 2. Now let's just see what that's going to do to each term. So first I'm going to take p over p minus 2, and we're going to multiply that times p minus 2, p plus 2, and what happens here is these two things cancel out. So what I'm left with in my numerator is p times p plus 2. Now when I multiply this times p minus 2, p plus 2, what is p minus 2, p plus 2? Well, it was originally this, so let's save a step and do 2 times p squared minus 4. Now when I multiply 8 times p minus 2, p plus 2, that's all going to cancel out with all this. So all I have left is this. Now I don't have any fractions, so I think that was worth deviating a little bit. Now let's see if we can simplify this. When I multiply through here, I'm going to have p to the second plus 2p plus 2p squared minus 8 equals 8. Let's just solve. P squared plus 2p squared is 3p squared. I've got a plus 2p and a minus 8 equals 8. Subtract 8 from each side, and now I'm going to have 3p squared plus 2p minus 16 equals 0. And here's a quadratic equation. So let me copy this up here. 3p squared plus 2p minus 16 is equal to 0. And let's solve this. We're going to do it by factoring. Since you have a quadratic that has a term in front of your leading term, you're going to need to use the AC method. So 3 times 16 gives you negative 48. We are looking for a pair of numbers that multiply to give us 48 and add up to give us 2. And it's a positive 2. So we're going to go with negative 6, positive 8. So we're going to rewrite that middle term, 3p squared plus 8p. It doesn't matter if you put the 6 or the 8 in front. 6p minus 16 is 0. And then we're going to factor by grouping. The greatest common factor here is going to be p. So you have 3p plus 8. And your greatest common factor here is going to be 2. Now remember, you're factoring out a negative, so it's going to change the sign of that binomial there. You've got 3p minus plus 8 equals 0. Alright, so we have p minus 2 times 3p plus 8 is equal to 0. Now, zero product property, take each factor and set it equal to 0. So p minus 2 is equal to 0. 3p plus 8 is equal to 0, and then solve. So we have p is equal to 2, and subtract 8 from each side and divide by 3. You get p is equal to negative 8/3. Now, we do need to check each answer. If I take p equals 2 and I go up here and plug it into my original expression, what do you see happens? Right off the bat, this denominator would be 0, which is not allowed. So this one does not work. Alright, if you take negative 8/3 up here, and I'm not going to do all the math, I promise you, if you put 8/3 in there, negative 8/3, you will get the correct answer. So there's that. This was a pretty complicated problem, and I probably wouldn't assign one of these, but I did want you to see that sometimes you get an answer that is not allowed. So that's the primary takeaway from this problem. If you check your answers and it's going to give you a 0 in your denominator, that answer is extraneous. So let's look at this last problem. X plus 6 over x plus 3 is equal to 2 minus 5x plus 12 over x plus 3. And once again, I run into a problem where normally, I would combine this into one fraction and then cross multiply and solve. But I see I've got the same denominator. So it would be an easy fix just to get rid of all these fractions altogether. And that's multiply all the way through by your denominator. Now you have to be careful, because in this problem there's 3 terms. This is 1, this is 2, and this is 3. So if you're going to multiply all the way through on an equation, you've got to be sure that every term gets multiplied. Alright, so I'm going to take my denominator, x plus 3, and I'm going to multiply every single term by x plus 3. Okay, now let's clean it up and see what happened. When I multiplied, these two canceled. So now I have x plus 6 here. When I multiply it times this 2, I've got to distribute, so that's going to be 2x plus 6. Now right here, I've got to be careful. These two things do cancel out, so I don't have to multiply anything, but this minus has to be distributed to this binomial before I can bring it down. So that's going to be minus 5x minus 12. Now, that looks a whole lot better, doesn't it? So let's clean up this side first. And 2x minus 5x gives me minus 3x. A positive 6 and a negative 12 is going to give me minus 6. Alright, simple solving. I would add 3x to each side. So now I have 4x plus 6 equals negative 6. Subtract 6 from each side. I get 4x is equal to negative 12. Divide both sides by 4. And x is equal to negative 3. Now let's go back up here and plug it into our equation. We're mainly looking for denominators. Now I only have one answer. So if I take negative 3 and I plug it into either one of these denominators, which is x plus 3, what happens? you get that 0 in there. So what is your answer to this problem? Absolutely no solution. There is no number that you can plug into this equation and get a true statement. Now, that's our last example for lesson 8. If you need some more examples, all you have to do is drop me a comment down below and I will be happy to make a whole other video with nothing but more examples. If there's something specific that you're having trouble with, let me know that too. And I'll see you back here next time. Bye.